So yesterday you learned how to graph these parametric equations that are where x and y are both dependent variables in terms of t. Well, as you remember yesterday, those curves, those equations had slope to them, and they also had concavity to them. So what we're going to do today is figure out how to, one, figure out the slope and figure out the concavity at a certain t value. First of all, let's go with finding the slope. Notice from these equations up here given, we can actually find dx dt and dy dt. So let's see if you guys can beat me and see who can do that the fastest. So dx dt, as we derive that, that's going to be 1 over the square root of t. And for dy dt, that's going to be 6t minus 2. So notice now what we have is we have dx dt and we have dy dt. But the question was, we want to find dy dx. We like Leibniz notation of this because it looks like a fraction. But if I actually take dy dt and I divide it by dx dt using your fraction rules, that's actually going to give you dy dx. So we're going to do that. This will equal dy dt divided by dx dt. And cleaning things up a little bit, this will equal square root of t times 6t minus 2, or in other words, 6t to the 3/2 minus 2t to the 1/2. And here we have dy dx. So what we actually have is we have the slope of that parametric equation. So the one that you graphed yesterday, this will tell you its slope, or in other words, it's dy dx. We're going to do this again a little bit later. Dx dt is actually the rate at which x is changing, and dy dt is the rate at which y is changing. If we were talking about a particle moving, dx dt would tell you the rate at which the particle moves left or right, and dy dt tells you the rate at which the particle moves up or down. We'll do that again later. But right now, we're not looking for those. We're looking for slope, and this is the slope of the function. Now that we have the first derivative, we're going to look for the second derivative. Here's where things get a little interesting. Notice here that we have dy dx, and it's written as a function in terms of t. Okay, so this is probably something new where we have the slope of the function, but it's not written in terms of x, it's written in terms of t. Note, I hope you remember that the second derivative is the derivative of the first one in terms of x. Or in other words, the second derivative is the derivative of dy dx in terms of x. So if we derive both sides, the left side is going to be d squared y dx squared. And when we derive the right side, since this is in terms of t, our derivative will be f prime of t times dt dx. And the reason for that is because this function is in terms of time, and using our chain rule, we want the derivative in terms of x. Another way of writing this is f prime of t divided by dx dt. And this will be something new. So now let's try that with our problem. I want the second derivative of this function. So what you're going to do is you're going to take the derivative, which is 9t to the 1/2. Oops, change that. 9p to the 1/2 minus t to the negative 1/2. And now you need to divide that by dx dt, which if you remember was t to the negative 1/2. Now when we simplify it, we're going to get 9t minus 1. This is our second derivative. Now for the easy part, evaluating all these things. What is dy dx at t equals 1? Well, that's going to be 6 minus 2, which equals 4. And what is the second derivative at t equals 1? Well, that's going to be 9 minus 1, which equals 8. What in the world does that mean? Well, it means that at t equals 1, at times t equals 1, the slope of that graph is 4. Or in other words, that graph, the function, is increasing. Whereas for the second derivative, when it equals 8, you should all probably know this, that at that point, the graph is concave up. And that's what we learn. We can still talk about slope and increasing, decreasing, and concavity of a function through the first and second derivative. So to sum up real quick, if you want to find dy dx, that's going to be dy dt divided by dx dt. And if you want to find the second derivative, you're going to take the derivative of that function that you got above, and you got divided by dx dt. And that is that.